Hello. Today I'm happy to present to you my first data integration and analysis project. The main goals were to efficiently collect, transform, and load a random dataset and drive meaningful insight through analysis and visualization. The dataset used in this project is the electric vehicle population data of the state of Washington DC. To be honest, I didn't really push much thought into choosing the dataset, which made retrieving meaningful insights a bit challenging. However, I managed to pull through. Like any data analysis project, you need to understand the dataset. So understanding the dataset was crucial. We explored its various columns like model year, electric range, EV type, and much more. And before starting the ETL process, you gotta ask some business questions or analysis questions. For our case, we defined some questions like how does the distribution of vehicle models vary across different years, which manufacturers have the highest number of vehicles, and many more.
After defining the analysis questions, we then implemented our project architecture in this picture, involving the physical machine and two virtual machines, and Snowflake as our cloud data warehouse. I'm not going too much details on the technical stuff in this video. If you want more details about the project, please check the doc in my GitHub. Okay, as I said before, we have two VMs. The first VM is responsible of retrieving the dataset from the public API of DataGov website using this Python script, and it's gonna send it to an SFTP server that is deployed using Docker in this VM. Okay, we're gonna start with the second VM. Of course, you need to install Docker first. You can find all the Docker installation steps in my doc. So this is, as you can see, Docker is running in the VM successfully. Okay, we're gonna see now the Docker file. So this is our Docker file. So basically we set up an Ubuntu image. Then we install the OpenSSH server. Then we create a user. SFTP user. We specify the password and home directory. And we create necessary directories and set up permissions. And then we expose port 22 for SSH access. Then we configure SSH to only allow SFTP for the SFTP user. We disable SSH tunneling and other SSH functions. And we start SSH daemon with a specified configuration. Okay, I already built the SFTP image. As you can see, this is our stopped containers. We're gonna start the container that of the SFTP server. Okay, so the container is running now. And we're gonna try to access the SFTP server in the localhost. Okay, so we're gonna run this command to connect to our SFTP server. We're gonna add the password that we specified in the Docker file. So as you can see, we are connected successfully to our local SFTP server. As you can see, we have the uploads folder in our SFTP. We specified in the Docker file that all the files of the SFTP server get stored in this upload folder. Okay, we're gonna try to ls. So this is our dataset, and I'm gonna try to delete it. And I'm gonna copy the name. Okay, as you can see, the dataset is deleted from the SFTP server now. Okay, as a proof that is working, we're gonna try to access this SFTP server from the physical machine. So this is my IP address of the IP address of the VM that contains the SFTP server. We're gonna try to ping it. It should normally work. As you can see, it's working. Okay, now I'm gonna try to access the SFTP server. We'll run this command. Okay, SFTP the user should add the IP address of the VM. And as you can see, I can access my SFTP server. Okay, now going back to the first VM. This is a script that sends the dataset to the SFTP server. Basically, you establish a connection with the API. You should specify the API URL key, your personal key. You create a request to the API. If the response is successful, you save it in this VM. So you should change the file path, and then you should connect to the SFTP server. You should specify the IP address, the username, and the password, and the port, obviously. You should specify the port number when you run the image of the SFTP server. We're gonna try to run the script and see if the dataset gets saved in the Docker in the SFTP server. Okay, cancel. Okay, Python. PD name. Okay, my bad. Okay, it takes a bit of time. Okay, as you can see, the dataset is retrieved successfully from the API to the local machine. Okay, the dataset is uploaded successfully to this FTP server. We're gonna try to reconnect to SFTP server using the physical machine. Okay, you can set the CT uploads ls. As you can see, this is our dataset. It's saved successfully in the SFTP server. Okay, the next step, you need to create a Snowflake trial account. You should save the username and the URL that they're gonna send you. You're gonna need it when you're gonna try to establish a connection with Snowflake in the Talend job. So the ETL process will be done using Talend in the physical machine. We have two jobs. The first job, we're gonna extract the dataset from the SFTP server. Then we're gonna transform our dataset using the TMAP component, download the dimension tables in the vehicle and the location to Snowflake. So I'm gonna display my dimension tables. So the first 10 records of deep location, and this is the first 10 records of the vehicle. In the first job, we establish a connection with the SFTP server. You should specify the IP address, the port number, username, and password. Same goes for the component of Snowflake, of establish a collection of Snowflake. You should specify the warehouse, the schema, the database name, and your credentials. I'm using here a T library load component to load a pretty old Snowflake jar, because the default one gave me an errors here. After that, we make sure that we have no duplicate rows in our dataset after extracting it. Then we drop records with missing informations, and using the tmap component to basically dropped unneeded columns and done our transformation. After that, dimension table to get loaded in Snowflake. So I'm gonna delete records on my data warehouse to repeat the process. I already deleted the location records. Gonna do the same for the vehicle. So the other rows records are deleted successfully. I'm gonna try to make sure. So as you can see, our records are deleted. So I'm gonna run the job. As you can see, the records are so the records are inserted successfully. I'm gonna do the same for the dimension vehicle table. I'm gonna deactivate this component. I'm gonna activate this one. Gonna rerun the job. As it seems, the dataset gets updated, because before we only had like 300,000 records. Now it's like half a million. Okay, now you gotta check. As you can see, we loaded our dimension table successfully. We're gonna check for team location. For this second job, we establish again a connection with this Snowflake account. There is a column in this in the fact table called range to max range ratio for each EV car, which is a calculated column. To calculate this ratio, we need the maximum value of the electric range of the whole dataset. We use this component to calculate this value, and we store it as a global variable in Talend. Then we make an inner join between the records of both dimension tables, and then we load the records of the fact table in Snowflake. We're gonna run our job. I already deleted the records in my fact table in Snowflake. You can find more info about my data warehouse structure in my documentation. Okay, so let's check in Snowflake. Okay, so as you can see, everything is okay. After loading the data to our data warehouse, we try to answer some analysis questions. like how does the distribution of vehicle models vary across different model years. As an example, you're going to find all the answers in the doc of each of these questions with a graph. As you know, Snowflake have dashboarding after execution of SQL request. It's pretty limited, but it's nice to have. And finally, the dashboarding. We created our dashboard using Power BI. In the first page, we can see some interesting informations, like what's the number of each make in the dataset, and what's the distribution of age of vehicles in the dataset and other stuff. In the second page, you can see the distribution of these vehicles owners by state or counties. Obviously, the most dominant state is Washington DC, which makes sense. And obviously, you can filter with model or make or model year or even region. Same thing goes for the first page. Obviously, dashboard was made by the old era with the 300,000 record. Obviously, the updated one might give different representation or data. That is for the video. Thank you for watching, and feel free to provide any suggestions in the comments so that I can make corrections and further improvement. Thank you.